Hello, now we will work section 2.4, linear inequalities and problem solving. And the first thing we're going to have a look is the learning objectives. We will learn how to use interval notation, how to solve linear inequalities, how to apply addition property and multiplication property, how to solve linear inequalities using both properties together, and solving problems modeled by linear inequalities. Basically, an inequality is a statement that contains the symbols less than, greater than, less or equal than, or greater or equal than. The equation we have the equal sign, so it is an equation. Inequality, you have the greater than sign, less than sign, greater or equal, less or equal. Okay. Next objective, the first objective, use interval notation. And solution of an inequality is going to be the value of the variable that makes the inequality a true statement. In the case of inequalities, you usually have a solution set. That means a bunch of solutions. The way of representing the solutions, we have basically three ways of representing the solution of inequalities. One is using set notation, and you see here, the set notation is x as x is greater than, less than, greater or equal than, less or equal than a. The graph notation is basically a line that goes to negative infinity on this side and positive infinity on that side. So it's an infinity line. And here is the border of the solution. That means this number a here. And if this is less than, so you're going to get this side of the line. This side of the line is the solution. Let's use a different color. This. And you need to represent on this line if this point here is included or not included on the solution. In this case here is less than, is not less or equal. So a is not included on the solution. And these represent that a is not included on the solution set. All real numbers that are lower than a. And interval notation. Interval notation is this representation here, where the solution goes from negative infinity to a. And then we need to say if the infinity, negative infinity or positive infinity, you're always going to use the parentheses. That means you never reach actually the infinity. So you're going to always use the parentheses. And here is going to be parentheses if a is not included, or this bracket if a is included. Okay? In this first example here, a is not included, so it's parentheses. All right. And have a look here, all the situations that you're going to have to representing graphing solutions in set notation, graph, or interval notation. And let's see this particular one here, where x is any real number. That means it's the whole line from negative infinity to positive infinity. Hello, Mateus. And let's work out some examples here. Example 1. So let's work example 1. Graph each set on a number line and then write it in interval notation. And the first example here is example A, a set of number x such that, remember this line here means such that x greater or equal than 2. How do we represent it? Using the graph notation and interval notation. Graph notation and interval notation. Well, graph notation, start with a line, and there's going to be a point here in the middle of this line. The number corresponding to this point here is this number 2, right? And the line goes from negative infinity to positive infinity. Don't forget the arrows to represent that this is an infinite line. And let me get a different color. Okay. Is 2 included or not included in the solution? See, is greater than or equal, so is included. Use this bracket here to represent that 2 is included. And it's greater than 2, that means this side of the line that is greater, that has all the numbers greater than 2. So this is graph notation. Now interval notation. Oh, interval notation, you go from 2 to positive infinity, right? This is positive infinity. Is positive infinity included, or as parentheses or bracket? Well, positive infinity and negative infinity, you're always going to use parentheses because you never reach, never is actually able to reach infinity. And 2 is included or not included? Yes, greater or equal, so it's included. You use this bracket here. So this is interval notation. The next one, let's do it quickly, that now we know how to do this, right? Letter B, the set of numbers x such that x is less than -1. So graph, draw a line, and there's a point here in the middle. This point is going to be -1. Find a different color. And don't forget to represent that this is an infinity line, a line that goes to infinity. And x is less than -1. Less than -1 is everything in the left section of the line, right? Those are the numbers that are less than -1. Is -1 included? No, not included. An interval notation, -1, we go first here, negative infinity, right? Negative infinity to -1. Negative infinity, always parentheses, and -1 included or not included? Not included, parentheses too. Okay. Next one, this is slightly different because now we have a interval with 2 limits. X such that x is going to be between 0.5 and 3. But x is greater than 0.5 and x is less or equal than 3. Or you can read like this: 0.5 is less than x, which is less or equal than 3. draw the line, and the line goes to negative infinity this side, positive infinity the other side. Now we have an interval, draw 2 points, and this is the lower number in the interval, the greater number in the interval. Is 5 included in the solution? Well, no, there's no equal here, right? So is parentheses. Is 3 included? Yes, brackets. And everything between 0.5 and 3 is the solution of this, is in this interval. And the next one, the interval notation. So 0.5 and 3. 0.5 is not included, 3 is included. This is the interval notation. Now, objective 2, solve linear inequalities using the addition property. And now we're going to apply addition property to solve inequalities. And the way we do this is pretty similar to the way we do with equations. And that means if we have A, for instance, less than B, then A plus C is also going to be less than B plus C. That means you can add the same thing on both sides, and it is still is going to be a true statement. And let's go to an example. Solve this inequality, and the inequality is x minus 2 is less than 5. You can add on both sides 2, add 2 on both sides of the inequality. So we're going to have x plus 0 less than 5 plus 2, 7. That means x less than 7. To represent the solution, then you can use this notation, the x such as x less than 7. The interval notation. Let's first do the graph notation. And here is going to be 7. 7 is not part of the solution. Everything less than 7 is part of the solution, going to negative infinity. And the interval notation is going to be negative infinity, 7 inside parentheses, right? Because here infinity is always parentheses, and here 7 is not part of the solution, so therefore parentheses. Another example. Now we have solve 3x plus 4 is greater or equal than 2x minus 6. And apply addition property. Add the same term to both sides to simplify. And remember that the objective is to have the variables in one side and the numbers on the other side. So we're going to get rid of this 2x here by subtracting 2x on both sides. 3x minus 2x, x plus 4 is greater or equal than 0 minus 6. And now we need to get rid of this plus 4 on this left hand side here of the inequality. So subtract 4, x, positive 4 minus 4, 0, greater than or equal, greater or equal than, negative 6 minus 4, negative 10. Right? A representation. First, using set notation. Set notation, we're gonna write here x such that x is greater or equal than negative 10. Graph notation, draw the line. Don't forget the arrows to show that this line goes to infinity. And this is going to be negative 10 here in the middle. And tell me, is negative 10 part of the solution? Yes, because it has to be equal here. So if it is part of the solution, you're going to use this kind of brackets. And everything greater than 10, the negative 10, I mean, is also part of the solution going to positive infinity, right? And interval notation, negative 10 to infinity, positive infinity. When is infinity is always the parentheses, and when negative 10, this number here is included in the solution, is part of the solution, is this bracket. Okay, let's go to another objective. Is that right? Yes. Now we're going to objective 3. Objective 3, solve linear inequalities using the multiplication and addition property. Now we're going to use both multiplication and addition property to solve linear inequalities. And the same thing we've done on equations, we're going to do on inequalities. If A is less than B, A times C is less than B times C. The multiplication property. But you just need to be careful now with this sign. If this C is a positive number, then this is true. If C is a negative number and A is less than B, C is a negative number, A times C is greater than B times C. You're gonna, if C is a negative number, you're going to shift the side of this inequality. And this is the only particular thing that you're gonna have for applying multiplication property to inequalities, which is different from applying to equations. Okay, example 4. Let's try to solve this example here where we have 1/4 of x is less or equal than 3/2. We can use multiplication property, and we can multiply by the same number both sides of the equation. We want to have only x here with no coefficient or coefficient 1 on this side. So multiply by both sides by 4, because we want to simplify here, right? Then we're going to have x less or equal than, simplify, divide 4 by 2, 3 times 2, 6. Write down this in set notation, using set notation, the set of x such that x is less or equal than 6. Use graph notation, then you have the line, don't forget the arrows. The line goes from negative infinity to positive infinity. Here in the middle is number 6, point number 6. And then let's find another color. Is 6 included? Yes. So it's this kind of bracket. And also everything that's less than 6 is also included. Perfect. And finally, the interval notation. Interval notation, we know this is negative infinity. So write down negative infinity, comma 6, negative infinity, always parentheses. When you have infinity, it's always parentheses. And 6 is included, is part of the solution, so is these brackets. Perfect. Now example 5, another example, example 5. Let's work this example. We have negative 2.3x is less than 6.9, right? And we want to have only x on this side of the equation with no coefficient or coefficient 1. To have this, we need to use multiplication property. As I was saying, we use multiplication property, and we're going to divide both sides by negative 2.3. Divide both sides by negative 2.3. And then, remember, you have a negative number. You are dividing, if you multiply or divide by a negative number, what do you have to do? You need to reverse, you need to shift the inequality. Now it's going to be like this. Okay? And negative 2.3 divided by negative 2.3 is x. It's going to be x. And 6.9 divided by negative 2.3 is negative 3. Okay, write down this solution. Set notation is the set of x such that x is greater than negative 3. Or using the graph notation, don't forget the arrows, and this point here is going to be negative 3. Let's get a different color. Is 3 included or not? Is negative 3 part of the solution or not? No, because there's no equal sign here, right? Is greater than negative 3, not greater or equal. So this is the parentheses. You can use the parentheses. Is everything greater than negative 3 is part of the solution? Yes. This is positive infinity. And finally, the interval notation, negative 3 to positive infinity. Negative 3 is not included. Positive infinity always going to be parentheses. Okay, now let's move on. Go to the next objective, objective 4. Solve linear inequalities using both properties of inequality. Gonna use both multiplication and addition property. And the step by step. Clear the equation of fractions by multiplying both sides of the inequality by the lowest common denominator. Step number 2, use distributive property to remove grouping symbols such as parentheses. Step number 3, combine like terms on each side of the inequality. Step 4, use the addition property of inequality to rewrite the inequality. And step number 5, use the multiplication property of inequality to get the variable alone in one side of the inequality. Okay, example number 6. We have 3x plus 9 greater or equal than 5 times x minus 1. Let's remember here the step by step. First step, clear equation of fractions, no fractions. Second step, use distributive property. So let's use here the distributive property, right? So 3x plus 9 greater or equal than 5x minus 5. 5 times negative 1 minus 5. All right. Next step, combine like terms. To combine like terms, you have to look at each side of the inequality to see if there are like terms to be combined. I don't see any like terms to be combined. Then next step, use addition property. Let's use addition property here, and we can first we need to isolate the x variable in one side. So let's subtract negative 3x from both sides. Let's subtract 3x from both sides. 3x minus 3x 0 plus 9 greater or equal than 5x minus 3x 2x minus 5. Perfect. Now we need to get rid of this. Let's add 5 both sides. So this is going to be 9 plus 5, 14, greater or equal to 2x plus 0. Okay? And now multiplication property. Divide both sides by 2. And if you divide both sides by 2, you're going to have x, 7. 14 divided by 2, 7. Greater or equal than 2x divided by 2, x. 7 is greater or equal than x. That means that x is less or equal than 7. It's the same thing, right? Remember, when you change the position of x, you need to change also the inequality. The inequality here is pointing to x. Here needs to keep pointing to x. Write down the solution using the notation, the proper notation. The set notation, x such that x is less or equal than 7. Graph notation, here, negative infinity, positive infinity. Don't forget the arrows, very important. This point here is going to be 7, and let's use a different color. 7 is included, so bracket, this bracket here. That means 7 is included. And everything less than 7 is also included. Right? And now interval notation. Goes from negative infinity to 7. Always parentheses when you have infinity. And here the bracket, because 7 is part of the solution. Example number 7. Example 7. Now we have, on example 7, 7 times x minus 2 plus x is greater than negative 4 times 5 minus x minus 12. Great. Remember the step by step. Let's go back to step by step. First, clear the equation of fractions, no fractions. Second, use distributive property. And we have some distributive property here, right? Here. And here. And using distributive property, we're going to have 7x, 7 times negative 2, negative 14. Plus x greater than negative 4 times 5, negative 20, right? Negative 4 times negative x, positive 4x, minus 12. Perfect. Next step. Check the step by step here. Combine like terms. Combine like terms. Now we have like terms to combine. We have this and that. And we have this and that. So combining this like terms here, negative 20 minus 12, negative 32. And like terms here, 7x plus x, 8x, and repeat, negative 14 greater than plus 4x. Great. Next step. Let's check here and remember the step by step. Use the addition property. Use the addition property of inequality. And the objective or addition property is to make the variables in only one side of the equation. So let's get rid of this by subtracting 4x from both sides. Let me move a little bit. Okay. Subtract 4x from both sides. 8x minus 4x, 4x minus 14 is greater than negative 32. 4x minus 4x, 0. And we need also to get rid of this, right? So plus 14 on both sides. 4x plus 0 greater than negative 32 plus 14 is going to be 18. Oh, negative 18. Don't forget the sign, negative 18. Step 5. Step 5 is use multiplication property. So multiplication property here. Divide both sides by 4. We can simplify. X greater than negative 18 divided by 4 is negative 9 divided by 2. Let me see if I got the right answer. Wow, ufa, yes. Represent now using the notation, set notation, set of x such that x is greater than negative 9 over 2. Graph notation, don't forget the arrows, arrow, and there's a point here, is negative 9 over 2, and using a different color. Negative 9 over 2 is not part of the solution, so parentheses, okay? And everything after negative 9 over 2 greater than negative 9 over 2 is part of the solution up to positive infinity. And interval notation, negative 9 over 2 and positive infinity. And here's parentheses. Always, infinity is always parentheses. And here, since negative 9 over 2 is not part of the solution, parentheses 2. Now finally, objective 5. Solving problems modeled by linear inequalities. And we will have here an example where I have a word problem. And let's read and understand first. You are having a catered event. You can spend at most $1,200. This is your budget. Let's write here budget. The maximum amount of money I can spend is $1,200. There's a setup fee for the caterer, which is $250. It's a constant fee, like it's a setup fee, and there's a cost of $15 per person. Find the greatest number of people that can be invited and still stay within the budget. So let's develop here. Let's write down here an expression that will represent the expending for this catered event. So we're going to spend $250 is one setup payment, right? And you're going to spend $15 per person. How many people will be invited? We don't know. The unknown usually is our variable. So let's call the unknown number of people x people. 15 times X is the amount of money you're going to spend. 15 times X, the amount of money considering the cost per person. And if we add, this needs to be less or equal than what? Than our budget. Right? This is the cost, and the cost needs to be less or equal than the budget. Let's find X, and remember, step by step, clear the equation of fractions, no fractions, use distributive property, no needs, combine like terms, no like terms here, use addition property, let's use addition property, and let's subtract 250 from both sides, subtract it from both sides, and we will have here 0, right, plus 15x is less or equal than 950. Is 1200 minus 250 is 950. And now divide everything by 15. Divide everything by 15, and you will have, simplify, x less or equal than 950 divided by 15. It's about 63.3. Number of people that can be invited, obviously that's for sure you cannot invite a third of a people, 0.3 people, so the maximum number of people that you can invite is 63. To stay within your budget of $1,200. And that's it for chapter 2.4.